this stage, delighted to introduce Dave Wynne with TickITplus, a universal model. Thank you, Dave.
Okay, thank you, Margaret. Welcome, everybody. Good afternoon. As Margaret mentioned, I've just got over COVID, so I may be coughing a bit, although it's surprising these days. I didn't really know I had it until I did a test for another reason. So I wonder just how many people are walking around with it these days. But anyway, so let's move on to the presentation. I'm going to focus on TickITplus scheme and how it could be considered some kind of universal model. Some of you may not have heard of TickITplus before, others may have heard of it or been on previous webinars. And some of you may actually be using it actively to help implement and improve your management systems. I'm going to go on a little short journey before we actually get to the TickITplus scheme itself, as it helps nicely to sort of back up the sort of premise of TickITplus being a universal model, or at least considered it in that way. It all starts really with quality and the very important link between quality and defined processes, or well-defined processes. So just before I get there, just a little bit of background about myself. 14 years at Aerospace, so airborne software quality manager, 4 years auditing with LRQA, although I still do contract work for them. 10 years as a principal consultant for CSC, a big commercial outsourcing organization. 14 years running my own business. I'm 9001, 20,000 lead auditor, TickITplus capability assessor. And I'm also a CMI dev lead appraiser. So I've been working for a long time in quality auditing, assessments, and process improvements. And I've seen lots and lots of systems. Some have impressed me, some have shocked me. But overall, it's built a picture of where things go wrong, where they can go wrong, and what actually a good system can look like. So first of all, it came very much to mind is, talking about quality, and the obvious way to demonstrate quality is to look at examples of non-quality, if you like. And I went through and sort of found a few examples. There was the Theric 25 problems in the mid-80s, injuries and deaths, overdosing of radiation, down to poor requirements analysis, really. AT&T long-distance phone failure in the 90s, down for 8 hours, lost $100 million, plus reputational damage, turned out to be one line of code. The Northeast US blackout in 2003, 55 million people affected for up to weeks without power. There was a bug in the alarm system that was telling the system was down. Ariane 5, 96, $500 million loss, reputational damage, poor design considerations. The Lockheed Martin F-22 Raptor 2007, $62 billion program, multiple system failures. Took them a few lines of erroneous code in 48 hours to do a fix on it. So you start questioning the testing, although that might be a bit unfair. We've got the Toyota ECM undemanded acceleration problem. It's led to deaths, injuries, litigation, compensation potentially running greater than 600 million. Poor firmware, bad coding standards. The US voters data breach in 2017, 198 million users affected because of an unpatched server. The RAF Chinook crash in 1994, 29 people lost their lives, and it turned out to be, after a lot of debate, turned out to be a software bug in the engine control system. Yahoo data breach 2014 onwards, greater than 1.5 billion users affected. And a single spear phishing click caused the problem on that one. And really something that's really home to hearts for many of us in the UK is the UK Post Office Horizon scandal. Many people convicted, job losses, families ruined, prison, suicide, potentially huge compensation. I'm obviously not going to say much more about it because there's an inquiry going on, but it looks around something around governance problems potentially there happening. So there's lots, and this was just a small sample out of pages and pages. In fact, yesterday at Sainsbury's, their internet crashed and it was absolute bedlam in the store. There wasn't enough staff to handle checkout because nobody could use the smart shop. People couldn't pay, so they were just dumping shopping all over the place and leaving. Again, because some part of the IT infrastructure was not working. Just goes to show you how much we depend on it these days. So that's sort of what's happening in the past. Where does the future go with some of these problems? I read the other day, AI technology. Something went viral around, I won't mention the guilty company, but one of the AI engines, when asked how to make cheese stick to pizzas better, they were told to use non-toxic glue. And another one said that geologists recommend humans eat a rock a day. These are only one-off examples, but we've got to think about where all this is going and how much people start to rely on and believe in what are we being told by these very clever AI systems. And the two pictures at the bottom were quite funny. I got them off the internet. There was illustrating how one group of tourists actually stopped at a red traffic light before moving on down the pavement because they took the traffic light literally. And another one where a pedestrian, actually stopped when the traffic sign said, "When red light shows, wait here." And people can just literally believe what they're being told. And if it's not as innocent as using non-toxic glue that they're being told, where does this all end up? So the systems are getting more complex. We're believing and relying in them a lot more. So we have to do a lot more to make sure. I won't say they're 100% perfect because we'll never really get there, but we've got to challenge and we've got to deliver systems that are as reliable and as useful as possible. So going that, I thought, well, things are still going in that direction. We're still having these problems and everything, but when you look at it, you've got to sort of consider the size of what we're talking about here. And I picked a few sort of examples of software and went and found out how many lines of code they were. So if we go back to the space shuttle, we're talking about 400,000 lines of code. And to be honest, I don't want to get into an argument or a debate about what a line of code is. Went through that debate years ago, but just relatively speaking, 400,000 lines of code. The F-22 Raptor I talked about, that had about 1.5 million lines of code in it around 2005. Windows NT, 1993, 4.5 million lines of code. The Mars Curiosity rover, 2012, 5 million lines of code. Boeing 787 in 2011, around 14 million lines of code. Sort of the upgrade of the military jet, the F-35, the latest, 24 million lines of code. Upgrade of Windows to Windows 7, nearly 40 million lines of code. One that surprised me greatly was the Large Hadron Collider, the thing that spins atoms and protons and things around in Europe, about 2008. 50 million lines of code involved in that system. And I think one of the most surprising one that came, although when you think about it, it's probably the case, certainly Toyota, with their problems with the undemanded acceleration, may very well be aware of, is a modern high-end car, a top-of-the-range car, could have up to 99 million lines of code in it throughout it. And there are countless CPUs, processors, computing technologies going on in cars these days. Just to put everything into perspective, we all know Google. Google has a library of software that they can call on, that they can use. They develop products very quickly because of this library. It's estimated at around 2 billion lines of code that they've got access to, which is sort of not surprising. They can produce new applications and systems in relative terms fairly quickly. However, putting all that into perspective, if we take the human genome, if we really want to start talking about artificial intelligence or intelligence and the human genome, then they estimate, or they sort of approximate the equivalent number of lines of code to be around about 330,000 million lines of code. So we've got a long way to go. But basically, the amount of code that we're producing in the systems is growing, exponentially. And if it's not the code, then it's the data that the code is using is growing exponentially. So where does this lead to? Well, it leads to something that I've known for a long time based on TQM principles, that the quality of the product is highly influenced by the quality of the process used to develop and maintain it. Now, that was very classically the case for manufacturing. If you've got a process that's poor, it's got damaged drill bits or blades and things, then the quality of the resulting product is going to be vulnerable, out of spec, etc. It's in that case more visible that you can see things happening a little bit more when you're talking about manufacturing and visible parts. But for software and IT systems, particularly software developments, the visibility of the product isn't there. So we rely a lot more on the documentation side, and we need good processes to help us assure that we're getting through that development in a satisfactory way. We're minimizing the chances of introducing defects. We're detecting things as we go along. We're showing progress, etc. And we've got to have a good process to achieve that. An illustration of a good process to me is the Rubik's Cube. I'm sure you all, or many of you will remember the Rubik's Cube. I sort of went and had a look at it, and I found out how many different starting positions there are for a Rubik's Cube. And that assumes that, each square is different, even though the colors sometimes are the same. But if we assume each square is a different starting position, there are actually 43 quintillion different starting states, okay? And the numbers down there. You can do the maths and you can work it all out and everything, but that's it. What I got to thinking about was, okay, I've got this problem. It's got 43 quintillion different starting states. How many methods are there to solve it? Now, I don't mean how many moves there are, but how many methods there are to solve it. How many ways can we go about solving a Rubik's Cube? And I came out with a sort of feeling that there are basically 3 ways to solve it. And really, those same 3 ways apply to whatever we do, right? Whether it's software development, whether it's system implementation, whether it's even manufacturing or training. There are generally 3 different types of approach that could happen. And I guess you probably will recognize some of them. The first one is randomly, right? We just go at it. It's usually how I unbox my new toys. I just randomly unbox them and start playing with them until I find out how everything works, and then realize that I threw something away that I needed. And that's typically how I go about doing the Rubik's Cube. I'll just set about doing it and see what happens. Excuse me. The second way is dubiously, right? Well, if I've got something to solve, I'll look for the shortest path to solve it. For a Rubik's Cube, I'll take it apart and I'll put it back together so that it looks like it's being solved. And yes, I've probably solved the Rubik's Cube, but I haven't really gone through all the stages of doing it. And if those stages involve doing certain things, particularly if this is a software development process, I could create code that satisfies the requirements, but it may not be efficient. It may not have all the error handling in it needs. It may not be maintainable, etc., because all I've gone is from start to finish. And it's dubious whether then actually I've solved the real problem anyway, even though it looks okay. The third way to do it is I can follow a process to solve the Rubik's Cube. Now, I don't know how many of you are experts at solving the Rubik's Cube. I'm certainly not, but there is a process. You can go on the internet and you can find it and you can follow it through. And it's a very clearly defined process. And each one of us could pick up that process and we could use it and we could all solve the Rubik's Cube in a certain amount of time. Now, initially, we probably take quite a bit of time doing it because we're following the instructions. But as you start to learn and develop the skill in following the process, okay, we'll then get faster at doing it. And as long as none of the conditions changed, over time will get very fast at solving the Rubik's Cube. And again, I don't know if you've seen, but some of they hold championships in solving Rubik's Cube. And I think it's something like somebody can solve 3 of them by juggling them in the air in 1 minute, 56 seconds as they're juggling them, which is quite amazing to watch. So, it's this type of thing. And when you follow this process, according to the internet, it's actually possible to satisfy any Rubik's Cube in any one of the 43 quintillion starting positions in a minimum of 26 moves. I think I did it once, and I think I was about there, which is quite amazing when you think that randomly you just go on forever, and dubiously you may achieve it, but not all the required steps that are required in it. So a good process is almost essential for achieving a desired outcome, okay? But that outcome we call quality. But, what does quality really mean? Well, as a 19-year-old, I got my first car. It was a lovely little green Mini, and that was great. I was really satisfied with it. In fact, what you could say, I were right good quality car it was. And I was happy. And the reason why I was happy was because it did what I wanted to do, right? It served the purpose that I wanted it to serve at the time. But that's not all, okay? It ran, it did what it did. You could argue it's a quality car because it did what a car does. But that's only one of the points of the triangle, if you like, because the second thing was I could afford it. I could actually buy the Mini that I needed to get me from A to B. And thirdly, I got it when I needed it. I just passed my driving test and I was desperate for a car. So all of those 3 things came together, and I was as proud as punch to have a car that I could drive around in, I could afford to operate and run, and it was there when I needed it for starting my first job. So to me, quality is all 3 of those things, not just it runs or it does what it's supposed to do. There's other factors involved. So when we look at quality systems, we're really not talking about quality systems. It's a bit of a misnomer, that phrase. We're talking about either a delivery system. So we're delivering something to customers' expectations, when they want it, what do they want, how much they're going to pay for it and everything. Or better still, we're talking about a management system. Or even better, we're actually talking about the business systems that we operate to deliver what is required, because these systems that we operate they're not stovepipes. They're not just individual components. They all work together with satisfying something. So I could deliver what it was required, but I could do it at such a cost that nobody could afford to do it. Or I could do it and I could keep the costs down, but nobody's going to get it for 10 years and they want it within the next year or so. So we've got to consider quality around that. And in fact, one of my old quality managers said to me that if we deliver something on time, but it doesn't work, we've got a quality problem. But if we deliver something that works perfectly a month late, we've still got a quality problem. But he said, which of those 2 scenarios will the customer never forget? And it will, of course, be the first one where we delivered it on time, but it was a mess. The second scenario, where we delivered it a month late, they'll be unhappy, sure enough. But they'll soon forget that because they've now got a system that works and is being used the way they wanted it to use. So quality is both ways, etc. So we now start talking about, well, all right, a business system. What is a system? Well, a system, first and foremost, must involve people, all right? If we're not involving people, then we've got some other kind of system. But what we're talking about is usually a business system or a system involving people doing stuff, okay? If we could get rid of the people, well, we might be talking about perfection, but even then, there's people involved in the process, in the system. The second component you have to have is tools, facilities, and equipment, okay? And that we need them because we can't do everything ourselves. So if we bring those 2 together in an uncontrolled way, we just basically get a total confusion, ad hoc, anarchy going on. There's no real structure to things. We're just really just wandering along, trying to do the best we can. And what we need there is some kind of process that describes how to put the people and the tools together and the facilities and the equipment in an effective and structured structured way. So we got to have a process. And if I pick a sort of standard model of a process, this is a classic view. You can, again, you can pick it up on the internet. You can have a look at it. It consists of inputs, outputs, controls, resources. The process itself in the middle is made up of activities. It's made up of templates, work instructions, whatever you need in there. Which is why I see a lot of people calling a work instruction a process, and it's not. A work instruction or a procedure are components of a process. A process is the higher level structure of how the thing works. Okay. But the real question of that is, let's take an example of a design review. So a design review, let's treat that as a process. We've got an unreviewed design going into the process. I'll ignore the controls and the resources at the moment, but that's the aim, is the input is an unreviewed design. And the output is typically, not always the case, but it's typically certainly a reviewed design, right? Sausage meat in, sausages out. It could also be design review records, maybe some metrics. There could be some corrective actions. There could be a no-go decision. There could be a need to do a re-review. But the real question on this is, we've got the input and we've got the outputs, but do we know whether it's a good process? Is it effective? And the outputs don't necessarily tell us that it's a good process. They tell us we did a process, we complied to a process, but not necessarily whether it was a good process or not. The analogy to that, of course, is just a process set written down in procedures, everything's there, but is that really a process? It's certainly a documented something, but I'm not sure whether it's a process or not. The analogy to that would be, is this a pocket watch? All the bits are there. There's a face, the case, top plate, crown wheel, mainspring, barrel, all of that stuff there. But the real question you would ask is, okay, but what time is it? So you've got all the bits, you can tick them off during audits, you can confirm they all exist, but you're not really saying whether it's a good audit, a good process or not, by just looking at the bits. You've got to start looking at more than just the bits. You've got to start looking at the outcomes. Okay, so we've got the outputs. Yeah, fine, great, we complied with them. But what did the process achieve? What was it that it did that actually was what we wanted it to do? And we can sometimes, in this example of the design review, is we could consider a design that is error-free, that can be implemented unambiguously, which saves time, rework mistakes, inaccuracies. And often, if you think about this, the outcome of one process is always seen as an input to the next process. So you can't often judge how good a process is until you look at where the process goes in the process chain, what's happening next to it, and whether it does what we want it to do. So the people to answer the question, for example, in a typical waterfall V model life cycle, or indeed in any other model, but is, did we do a good design review? Well, the coders are keeping on asking us for a clarification of the design. They keep finding ambiguities in it. They keep finding bits missing in it. One could then argue that the design review wasn't really as effective as we could have really done, because we should have been finding those things during the design review stage, not during the actual implementation and coding phase. So that now leads on to, we know the value of a process. We've got to have it. We've seen it in the Rubik's Cube. And if you notice the Rubik's Cube one, if you picked up on it, the way the process is described was through pictures. Now, courtesy of a colleague of mine, a previous colleague of mine who did an experiment with this, and I followed it up in some training courses. We did a little experiment using a Lego model. I think he used a boat, I used a small car. And I went away and first of all, I wrote down almost 5 pages of written instructions on how to put the Rubik's Cube, the Lego model together. Right, no pictures, just the pieces and my written instructions, as you can see up there, literally telling people to pick pieces up, find pieces, put them together in a certain way. The second method I gave to the second team in the training was just the front picture of the Lego model. Okay, I said, there's the picture, there's the parts. And the third one is I gave the Lego model and the Lego instructions, which actually have won awards for being a very effective way of communicating how to build the Lego models. And the results I've run it a few times over the years, and I've collected the data from it. And the results are quite interesting, because you would think that the third one, the Lego model with the instructions, would be the one that would be the fastest to do. Actually, what comes out is the second one is the quickest usually to finish. Around about 13 minutes to do it. Then we get the one that following the actual instructions, around about 17 minutes. And finally, we don't get, I have to stop them because they just don't really get anywhere at all. The interesting thing with the second one is this: yes, they finish. It's a bit like the Rubik's Cube being dismantled and put back together again. They usually finish, and they usually end up with some parts. They just don't know where they go. So it looks right, but they haven't got all the parts included, because some of them you can't observe from the actual picture on the front, which is why they tend to finish a little bit quicker. The third example, obviously, they finish pretty well perfectly, and there's no bits left over because they followed the instructions. So when we're writing processes, we've got to structure them or write them in a way that's sort of appropriate to what we're trying to achieve. And in some cases, written instructions are the appropriate way to do things, and in some cases they're not. If we move on to sort of a model of that, we've got the sort of model in here, 4 quarters. We've got policy, process, training, and measures, sort of fundamental to what's going on in a process. We've got the people and the tools. And we usually start off with you could consider a sort of an unskilled, inexperienced, unfamiliar person using none or manual tools. So what we need there are very precise instructions, regular supervision, and checking. They've got to be supervised pretty well much of the time, because they're not very experienced in it. They may be new to it. They've got no tools that are doing things for us. As we develop the people to more experienced, skilled, and become familiar, then you can start moving away from instructions and start giving them guidance on what to do, because they've got the competency to do the interlinking steps. And they only need periodic supervision or periodic checking. If we given that, and we start evolving the tools, so we started using automated tools or AI tools, then we can start moving with fairly unskilled people or new to the process. We can start relying more on manuals rather than instructions, because the manuals tell them how to use the tools. They may need periodic supervision, but probably regular checking to make sure that they're following the manuals correctly. And finally, if we combine everything together, we've got experienced and skilled people and very advanced, sophisticated tools, then really all we need is reference materials for them to observe what they do against what other people are doing, and probably more around performance-based monitoring, measures, and metrics than any kind of supervision or checking. And ideally, to run processes efficiently as possible, we want to be moving our management system documentation, if you like, towards that top right quarter, where we can rely on these competent people using as most advanced tools as that we can afford or that we can get our hands on. So we've got processes now. We've documented them in the right way, hopefully. We then move on to how do we integrate them into the business. And as I said earlier, businesses aren't separate bits of components that sit on their own and do things. So safety, security, energy, environment, development, services, they're not all separate. They all overlap with each other. And I've left out other things like finance and management reporting and all of that stuff, but they're all highly integrated. I could create the safest product in the world, but I may cost so much to do it, I can't deliver it. I could use zero energy, but it's going to take so long to develop something, it's not worth developing it. I could create something very quickly, but then leave the servicing group with the problems of actually having to deal with the problems and the issues. So things are, and they should be, very highly integrated. we're not, for example, we're not clauses of a standard that just work in isolation. We're an integrated model that works together. So bringing all of that together, we've got our processes and engineer, we've got integrated systems, we've got documentation, we've got processes with outcomes, we've got problems that we need to try and resolve, we've got a way of documenting everything. All of this is coming together to the people who are running in the organization, trying to satisfy and solve all this in an effective way. So, how do we do this? This is the big question, the age-old question. I'm sure you're all familiar with it. Okay, well, what I'm getting to now is hopefully TickITplus can help do this. It is trying to address all those problems in some systematic, single approach method to do it. So let's just have a quick look at how the TickITplus scheme does this. So we take, for example, the core scheme. There are many documents within it. This is the base process library, which, again, for those of you who've used TickITplus, you'll know what's in here, but I'll go through a little bit of detail of this to help explain how it is. But that's only the processes. Around the TickITplus scheme, we have other things. We have scope profiles. We're trying to develop the auditors to be more IT and software subject matter experts around it. It's a very well-defined scheme. There's a core scheme requirements that says how it works and what's involved and what has to be done by the certification bodies, by the organizations using it, by the accreditation standard organizations, etc. And it does try and ensure that you get repeatable results in the way it's constructed. If you ask one auditor to come in and use the TickITplus scheme to assess an organization, and then a couple of weeks later or a month later, or whatever period later, if there hasn't been too much context change in the organization, and ask another auditor to do it, they should reasonably coming out with the same kind of results. It does mappings to the requirements and reference standards, and it's also got the concept of capability levels. Okay, but for the sake of this presentation, I'm only going to talk about the requirements and reference standards, because that's what I believe drives the key to actually causing TickITplus or allowing TickITplus to be seen as some kind of universal model. So let's get into the TickITplus scheme. First of all, the base process library, that's the key document that you would use if you're an organization wanting to adopt TickITplus and use it as an improvement model or a development model. There are 40 software engineering and IT related processes. So the important thing here is they're not just software development, they are IT related. So that could be security, service, etc. And they're in the 40 processes are all within the base process library. Now, clearly, not all organizations want to implement all 40 processes. That's understandable. But what we've got is a series of types of process. We've got type A, which are mandatory in all cases, and they mainly cover ISO 9001 clauses 4, 5, 6, 7, and 9. That's predominantly where they're addressing. We then have type BC. B are mandatory to the particular scope you're using, and C are optional. They mainly cover ISO 9000 clauses in clause 8, but they do expand a little bit into the other clauses to help support those other clauses. We have a single type C process, which is optional in all cases. And then we have a couple of processes that are mandatory when you do the gold and platinum levels. And as I said, I'm not going to talk about the capability levels, but needless to say, there are different levels of maturity within the TickITplus scheme, and the highest two are gold and platinum. And when you do those two, you then implement 2 additional processes to help you achieve that level of maturity. So we've got the 40 processes, and as I said, you don't need to implement them all. You have to implement the type A ones, because they're the sort of mandatory clauses within 9001. And the question is then left is, well, which of the type BC do you have to implement? Well, the way we've done it in TickITplus, and this is the first of our sort of tailoring approach to it, is that we've introduced what we call scope profiles. And the scope profiles are designed to sort of suit the primary aim of your certification or the primary aim of your business context. You need to pick at least one if you're going to go for certification. If you're not going to go for certification, by all means, use the TickITplus based process library and just pick the processes and see how they work. You always run a little bit of a risk that they are integrated and one talks to another. So picking one in isolation may not give you the value as picking a set of them. But if you're going for certification around it to be recognized as achieving a level within TickITplus, then you need to pick at least one scope profile. And there are a bunch there. We've got systems and software development and support. We've got information management. So if we just take a quick look at this, what the scope profiles do, excuse me, is they select which of the type BC processes are applicable as a minimum, I'll emphasize that, as a minimum to that scope profile. So if we look at legal and compliance, we've got that set, okay, the non-highlighted ones, so security, decision, information, finance, etc. If we go to service management, we've got a different set, which includes things like operations management. It should have service management in there as well. Apologies, that's got should have been viewable. Systems and software development and support. It's got architectural design, integration, etc. And I can go through the rest of them. So you can go through and select which ones you want. And it will tell you from the type BCs which ones are applicable and which ones work together to actually achieve a holistic management system to deliver what you want it to deliver. And of course, you can pick more than one. You could have two. You could have systems and software development and support, and you could have service management. So they can come together, and you would do all the processes that are in both of those scope profiles. This, by the way, excludes the type A because they're mandatory in all cases. So that's how we can tailor TickITplus in a universal way to suit different organizational contexts and what you want to focus on and what you want to improve and what you want to demonstrate to your client base. Within each process is our second way of tailoring or creating a universal model that can be suited to any organization. We'll start off by looking at how every process is constructed. Okay, so we have a header bar that tells us what the process is, what category it belongs to, what type it is, and most importantly, a brief sentence that says what the purpose of the process is. We kept it very brief because we didn't want to have a lot of debate and argument about what words mean. We've tried and kept it as simple as possible to explain what we're trying to do in this process. Every process then has an outcome. If you remember back to my process model, that said, you know, we don't just want to worry about the outputs. We really ought to worry about the outcomes in order to judge whether the process is doing what we want it to do. Not that it's just generating stuff, but it's actually achieving what we're trying to get it to do. So we've defined what an outcome could look like if you implement that process in the way that we've said. You should expect to see these types of outcomes happening. Every process has one or more best practices. And these are what we hope to be very easily read, easily understood steps within the process. They could be work instructions if you wanted to elaborate them. They could be procedures. They could be based on templates, work products, or whatever. But they are simple steps that says, if you go through these steps, you will satisfy the purpose and you should generate the outcome. Along with that, because processes have inputs and outputs, we've tried to indicate for every process what's typically the input to that process and what is typically the output. Now, that doesn't mean you have to generate these inputs and, identify these inputs and generate these outputs. You have to have something that is equivalent to them, that satisfies the intent of them, because they're the communication mechanism through the process. They almost control the process flow, if you like, and they can be good indicators that the process is being complied with, not necessarily achieving its outcome, but certainly that we are complying with what the process has said. And finally, every process has mappings to the standards, and all processes have mappings to 9001 because that is the core standard. So we've mapped everything in TickITplus to some area of 9001. And in this example of decision management, just one I picked, it only maps to 9001. And as you can see, it's not a one-to-one mapping. And this illustrates that businesses are made up of multiple components to achieve certain things, not maybe as if the standard would suggest, which is just nice separate clauses. Those clauses have to work together to achieve something. And the TickITplus is very clear about what clauses you need to use to achieve one of the base practice steps. Okay, and you can go to those clauses and you can read further details and further information about it. But we've done the mapping for you. We've said to manage key business decisions, you want to be looking at the following the following clauses within ISO 9001. That's a very simple example of how a process looks, and they all have that basics to them. If we move on to the next example, this is where there are multiple standards involved. So if we take customer focus, we've got the same structure, purpose, outcome, base practices, inputs and output work products. And now we've got mappings to multiple standards, 9001, 20,000, 27,000. Now, if you're using TickITplus and only going for 9001 certification, those other mappings are irrelevant. You don't have to worry about them. But if you're trying to create an integrated system between security, service, and development, then we've done the mapping for you. We've shown you where all the clauses down to sub-clause level have overlapped and are linking together to provide you with a holistic view of how to create a customer-focused process that covers all the standards that are involved. So that's the second way that we've created sort of this universal model for organizations to use in a way that suits them. The third way we've done it is through additional outcomes. Now, this example here is of 9001 BS 10754, which is trustworthy software, and ISO 26262, which is automation functional safety. And in this example, we've still got the mappings, as you've seen here. So, you know, estimate system requirement sizes, we've mapped to 9001, and we've mapped it to ISO 26262. We've got managed system requirements mapped to 9001 and BS 10754, etc. But in some cases, the standards bring with them very much more specific additional requirements that 9001, if we tried to map it directly, would mean that everybody that did TickITplus for just 9001 would have to start doing all these very additional things, which wouldn't be right and proper for most organizations. So what we've done there, oops, I'm sorry, previous, I've gone too far. What we've done there is we've added on additional outcomes to the process. This should have shown you what those outcomes were, but underneath here, underneath the outcome column, there are additional outcomes, and they map to additional clauses of just the relevant standards. I'll make sure that slide's correct in the upload of it. Okay, so we've got a third way of tailoring. We can add additional outcomes that only belong to a particular standard, right? So what have we got so far in TickITplus? I'm just conscious of my time. We've got a TickITplus based process library, and we've mapped the following standards, 9001 being the core standard, ISO 20000, 27001, 2013 and 22. We've got BS 10754 for trustworthy software or trustworthy systems, 26262 functional safety, 12207 for systems and software life cycles, 15288 for system life cycles. So we've already mapped them into the base process library. We're now working on some further standards. At the moment, we're working on AQAP 2210, which is a NATO software QA requirements standard. And we're also working on AS 9115, which is a supplement to AS 9100 for software. And we're also looking at some other standards being considered around ISO 61508 for functional safety and 62304 for medical devices. And we're open to considering additional standards as well, because many of these standards have a very common, similar basis to them. And when you certainly look at them from a software development side, there are very similar terms throughout them all. Okay, benefits of adopting TickITplus. So far, I've really just talked about the green areas, providing specific ISO 9000 certification for IT, covering multiple IT-related standards and benefiting clearly from defined processes with outcomes. There are other things in there which could be the subject of further webinars, improving auditor competence, focusing on true process-based models, and enabling organization improving using capability levels, practical route to other capable models such as CMMI or SPICE, encouraging organization participation in assessments, offering better consistency in an assessment approach, and ultimately promoting real business improvements, not just creating more stuff from procedures and processes, but actually generating real outcomes in the business. So to finish with, a great quote that I use a regular time is from Deming. In God we trust, everybody else bring data, because ultimately demonstrating outcomes can only really be done on the basis of data showing that the outcomes are doing what you want them to do. And it starts really from a premise of having these good processes. If you have these good processes, like the Rubik's Cube process, like the Lego example process, like well-structured processes in TickITplus, then you can do repeatability. So I can measure the people doing Rubik's Cube following the process, and I can see whether they're actually getting better in what they're doing. I can measure people following the Lego example and see whether they're actually benefiting from it. With measures, I can start doing predictability. I can start predicting whether a group, a department, a function, a project is not going to achieve what I'm expecting from the measures, from the repeatability. And I can detect it early enough to actually analyze and understand why they're going off course. And I can do action early before it turns into a real problem. With predictability, we've got early prevention. And with early prevention, I can then achieve better customer satisfaction. Early prevention means I don't do as much rework, so things are delivered on time. They don't cost as much as if I've got to pour more money into it to get it back on schedule. And they probably do what the customers want them to do because I've detected things early in the process. And all of that, as I go right back to the very beginning, leads to this is quality, and we've achieved what we want to achieve. So that really, in a fairly rapid amount of time, although it's passed very quickly, is what I wanted to present. If you do want further information on TickITplus, please visit the TickITplus website at tickitplus.org. Specifically, there are Kickstart guides, the core scheme requirements, the base process library, the requirements for assessors and practitioners. They're all free downloads. You can just download and use them. And that really brings me to the end of my presentation.